Hello, Math 1 students. Welcome to our video lessons for Chapter 3. Today we are studying 3.2. Excuse me, little dodo bird. 3.2 is called linear functions. Linear functions. The root word for linear is line. Hence why linear functions have a graph that is a line. So we're studying functions that have graphs that look like straight lines. Lines that are never ending in both directions and infinitely straight, with infinitely many points in them. So a linear equation, that's our first vocab word, linear equation, is an equation that can be written in the form y equals mx plus b. Hopefully you've seen that before. That is our very favorite equation of a line, where m and b are constants, meaning that m is a number and b is a number, and x and y are variables. So a linear equation would be written y equals some number x plus some other number. Now there are two types of functions, multiple types of functions, linear and non-linear. So if it's a linear function, it has a graph that is a non-vertical line. If the graph was vertical, picture a straight line up and down. Notice this would not be a function because this would fail the vertical line test. All of these outputs have the exact same input. But any other line constitutes a function, except a vertical one. Linear functions also have a constant rate of change. Constant rate of change, and that's going to be represented by this m. The m stands for our rate of change. A nonlinear function is the opposite. The graph is not a line, a straight line never ending in both directions. A nonlinear function also does not have a constant rate of change. So two things we're looking for when determining whether it's a linear function or not. Let's take a look at a couple graphs to start with. If at any point you need to pause this video so that you can write down the notes, please feel free to do that. This first graph, it's called a parabola. It is a function. It does pass the vertical line test. If I slide my pencil across it, it does not hit the graph at 2 points. Therefore, it has exactly one output for every input. But as you can see, this graph is not a straight line. It looks more like a U. So this is non-linear, not a line. This second function, on the other hand, again passes the vertical line test. If I slide my pencil across, it hits the graph at exactly 1 point at each input. Therefore, it has exactly one output for every input. And as you can see, it is a line, a straight line that goes infinitely far in both directions. So that's what a linear function looks like. It's a line. We can also determine linear and nonlinear from a table. From a table, we're going to need to see if it has a constant rate of change. So let's examine this one by one. First, let's look at the x, or the domain, the input. From 3 to 6, the change is plus 3. From 6 to 9, the change is plus 3 again. And from 9 to 12, the change is plus 3. Therefore, in terms of the input, x, we have a constant rate of change. It is plus 3 every time, the same exact number. Now let's see if the same thing holds true for y. From 36 to 30, we are subtracting 6. From 30 to 24, we're subtracting 6 again. From 24 to 18, we are subtracting 6 again. So that is a constant rate of change. Constant in the input and in the output, therefore that first table is linear. Constant rate of change. Both the input and the output must have a constant rate. Let's check this part B of example 2. From 1 to 3, we're adding 2. From 3 to 5, we are adding 2 again. From 5 to 7, we are adding 2 again. Looks very constant to me. Adding 2 every time, exactly the same number, and adding each time. Let's examine the y's. This might be linear after all. Did you notice it says nonlinear? Okay, that's a clue. 2 to 9, that's plus 7. 9 to 20, whoa. Do you think that's going to be plus 7? I do not. That looks like plus 11. Right there we have an inconsistency. This is not constant. I see a plus 7 and a plus 11, so this is non-linear. Not a constant rate of change. So we have to check both the input and the output. In this case, the output failed. Therefore, the whole function fails. It is not linear. We can also look at equations of a line. Here are a couple equations of a line. Again, if you need to pause the video to catch up, that's perfectly fine. In order to be a linear equation, we need to be able to write it in the form y equals mx plus b. Y equals mx plus b. So this first equation, I think I could write it like this. There's no x, so that makes me think that my m is 0. So I could write this function as y equals 0x, because what is 0 times anything? 0. 0x plus 3.8. So the m is 0, there is no x there. My b is 3.8. So this is linear. That one is linear. The second one, again, I would like to write it in the form y equals mx plus b. This time I see my x here, but I have a problem. There's the square root in the way. Is there a square root in the formula y equals mx plus b? No, there is not. There's no way for me to rearrange and get rid of this square root, so this is non-linear. We'll study these types of functions later. There's no way for me to rearrange that and get rid of the square root, so non-linear. The third one, I would like to write it y equals mx plus b, which is our favorite equation of a line. I see the y equals, we got that part going for us, 3 to the x. So here x is an exponent. I need x to be a base. I can't have x being an exponent, so this is also non-linear. There's no way for me to rearrange it and write it as y equals mx plus b. Over here, y equals 6 times the quantity x minus 1. I want to write it in the form y equals mx plus b. I do see a single x and I do see a single y. That gives me hope that this might be possible. Let's see, if I distribute this 6 to both things, 6 times x is 6x. 6 times negative 1 is negative 6. So y equals 6x minus 6. That looks perfect. I have a number in front of my x and a number after my x, m and b. So that one is a linear function. That one is a linear function. The next one, I have an x squared minus y equals 0. I want it to look like y equals mx plus b. Looks like my y is on the left right now. I could rearrange this so that I could move my y over to the right side. Y equals x squared. But we have a problem. There are no exponents in y equals mx plus b. And there's no way for me to get rid of that squared. If I moved it over, it'd be a square root. So that squared makes it non-linear. A line does not have an exponent in it, other than the implied exponent of 1. What about this last guy? I want it to look like y equals mx plus b. Let's see if we can do some rearranging. I can move this x over 2 over to the right side, so y equals negative x over 2 plus 3. That's looking mighty close, but the x, it's not supposed to be in a fraction. What number is really in front of that x? It's a 1. So really, this equation is y equals negative 1/2 x plus 3. And that is in the form of y equals mx plus b. This negative 1/2 is our m, this 3 is our b, so this is linear. That last guy is linear. All right. So if you need to pause the video at any instance or go back, please make sure you have all these notes copied. Then click on the Linear Functions 3.2 Part 2 for the rest of the notes.